Hey everyone, and welcome. So, you're ready to dive in and write your very first bit of C code, right? Awesome. You are in exactly the right spot. Let's get right to it. So, have you ever really thought about that? I mean, how do you actually give a computer its very first instruction? Well, it turns out there's this tradition, this rite of passage, really, for pretty much every programmer out there. And that's exactly where we're going to start. And ta-da! Here it is, the legendary Hello World program. I know. It might look a little intimidating at first glance, kind of like a secret code. But trust me, these few lines are the absolute key. You've got this include thing, a main function, a print command. Let's break it down and see what's actually going on here. Okay, so let's become code detectives for a minute and pull this thing apart, piece by piece. Don't sweat it. Every single part has a job, and I promise, once you see it, it's all going to click. All right, first up, that hashtag include stdio.h line. The easiest way to think about this is like you're getting ready to build something, right? So you grab your toolbox. stdio.h is that toolbox. It stands for Standard Input Output, and it's packed with all these pre-made tools. By including it, we're basically telling our program, hey, heads up, I'm going to need some of the basic tools, especially the one for printing stuff on the screen. Okay, next up is int main. This is super important. Think of your entire program as a house. Main is the front door. It's the only way in. When you run your code, the computer's first question is, where's main? It finds it, opens that door, and starts following the instructions inside. Every single C program has to have one. So once we're inside that front door, what's our first instruction? It's printf. And hey, look at that. That's one of the tools we just grabbed from our studio.h toolbox. Its job is simple. Take whatever text is inside those quotation marks and just print it to the screen. Now see that little semicolon at the end? You can't forget that. It's like the period at the end of a sentence. It tells the computer, okay, this instruction is done. Move on to the next one. And last but not least, return 0. This is basically our program politely telling the operating system, hey, I'm all done and everything went great. That 0 is just the universal code for success. No problems here. It's how we make a clean getaway. Okay, pretty cool, right? We can get the computer to say hello. But that's, well, it's just static text. The real magic of programming happens when you can work with stuff that changes. Do math, handle data. So the big question is, how do we make our program actually do something, like a calculation? And the answer to that question, the key to unlocking all that power, is a concept called variables. This is a huge deal. Variables are basically how our programs remember things. It's what turns them from a simple to-do list into a dynamic thinking tool. Just look at the difference here. On the left, sure, we're adding 25 and 75, it works. But what if we want to add different numbers? We'd have to rewrite the code. It's stuck, it's rigid. Now look at the right. This is the good stuff. We're using variables. We've created a little container called num1 and put 25 in it. Another one called num2 holds 75. Then we just tell the computer to add the containers. This is way better, right? It's flexible, it's easier to read, and we can change the numbers in those boxes anytime we want without touching the main calculation.
So really, that's all a variable is. It's just a labeled box in the computer's memory. You give the box a name, like user age or total score. You tell the computer what kind of stuff is going to go in the box. In our case, int for integer or a whole number, and then you pop a value in there. That's it, a named spot to hold some data.
Now, you can't just go wild and name these boxes anything you want. C is a little particular about it. There are some rules, so let's go over them real quick.
Okay, here are the big ones. You got to start your variable name with a letter or an underscore. No starting with a number, that's a big no-no. You can have numbers in the name, just not at the beginning. Also no weird special characters or spaces. And this one gets a lot of people. C is case sensitive. So age with a lowercase a and age with a capital A are two totally different variables to the computer. Finally, you can't use words that C already has reserved for itself, like int or if. Makes sense, right? You don't want to confuse it.
All right, we've written our code. It looks good to us. We can read it. But there's one more massive step. The thing is, the computer's brain, the processor, it doesn't speak C. It speaks its own language, which is just a bunch of ones and zeros. So what we've written is for us humans. We need a way to translate it for the machine. And that translator is called the compiler. This is the hero of the story. It's a special program whose only job is to read our nice, human-friendly C code from our .c file and translate it line by line into the raw machine code, the ones and zeros, that the computer actually understands.
So the whole workflow is actually a really simple three-step recipe. Step 1, you write your code in a text editor and save it. Step 2, you hand that file over to a compiler. A really common one is called GCC. And step 3, the compiler spits out a brand new file, an executable program, and you run it. Write, compile, run. That's the cycle.
And if you're using a command line, this is literally what it looks like. You type GCC, that's the name of the compiler, then the name of your code file, like hello.c. That little -o part just means output, and it lets you pick a name for your final program. Hit enter, the compiler does its magic, and boom! If you didn't make any typos, you've got a program ready to go.
And believe it or not, that's it. You've just learned the absolute core building blocks of C. You now know how to write instructions, how to make your program remember stuff using variables, and how to bring it all to life with a compiler. You can officially make a computer listen to you. So, the only real question left is, what problem are you going to solve first?